Prices.
Index of 8 grain prices. Thank you, Ray Thoms of the Cycles Research Institute. We have a graph here from 1548 to 1818. It's a long scale of these grain prices, 8 of them. What do we have?
So one of the things, if someone downloads the CAT software, they will get with it a whole bunch of different folders, some with daily prices, some with weekly, some with monthly, some with annually, and so on.
That's a nice bit of data, and they can download the CAT software from cyclesresearchinstitute.org, cyclesresearchinstitute.org. Okay, thank you.
And so this is some of those, and I've just, because the individual ones sometimes don't have that many measurements, and that will be not quite so reliable, I've used an index of 8 of them, which gives you a better measure. And so this is what's happened, and people don't often realise, because in the last century we've had inflation. We had more inflation, less inflation, but we're always going only one way. Historically, over these long periods, often prices went up and down. So we've got here, you know, at the end of 160 years, just where we started, a little bit up here, but this is looking like a 200-year cycle, isn't it?
It is. It is, again.
We've got 260, 270 years, and we've done about 1.5 cycles, so it's looking like it might be something like that. Now, which means it might have gone down the next period.
And you've found many cases of 104-year cycle, 208-year cycle, and other things.
Yeah, and the sun and so on. So it's highly likely that the suns will affect that. So this one, it's a little. This is here for a couple of purposes, to show there are cycles in these things. Also, we will reference it to CATs as well, as in that the fact that the data is in there, and people can explore this further and look at the individual ones if they want.
Yes.
This is the spectrum of the previous graph.
Yeah.
It's monthly data, so all the figures are in months.
Yes.
And one of the things that stands out straight off, it's looking for cycles. It doesn't know that there's 12 months in a year, right? Program is looking at this. It doesn't know what a year is. It's just got data at regular intervals that happen to be a month.
Okay.
And it's found cycles at 12.000 months, 6.000 months, and 4.000 months.
That's extraordinary.
So that's
3 decimal places to the 0.
Yeah, yeah. And so those, and you can see they're quite strong. So in other words, there's an annual cycle.
Yeah.
The annual cycle is not a sine wave. It's got some other shapes to it, which means there's a half annual and third annual, and there will also be a quarter and a fifth and a sixth.
Okay, so it's responding to our yearly structure, but it doesn't necessarily have periodicity.
It has periodicity, but it doesn't have necessarily a sine wave shape.
Ah, very good.
It may come down more slowly than it goes up, or whatever like that.
Of course.
And it may have some bit of another shape, or a flat bottom, or whatever.
Yeah.
But the different ones there are present.
Yeah.
There are other cycles present in here in months as well, and a couple of ones either side of the year. These are plus or minus 0.060 less and 0.057 more, so we can say that this has got about, we're taking about 200 cycles, or just over. It's making, each of those is making beats with that. In other words, it's detecting a 200-year cycle in it as beats of the annual cycle.
Indeed.
So that the annual cycle is being affected by something on the 200 years or just over.
Again.
These are all in months, so this would be about a 5-year, about a 5.6 year, and so on.
Yeah.
And that one would be about 53 years, which is the Kondratiev cycle that does exist.
The Kondratiev wave has been found over the decades.
Yeah, over the
for quite a lot of time.
Over the hundreds of years. Yeah. So that's that. Now these ones are interesting. So I had a little look at the cycles that were near fractions of a year, and this is what CATS came up with: 12.00015 months, 6, 4, 3, and 2.4. So a year, a half a year, a third of a year, a quarter of a year, and a fifth of a year. And what I was particularly looking at here is, we know what the real periods for these ought to be if they are following the seasons. So I've taken the difference between the real number and this. So that's just the change from 12 or 6 or 4 or 3 or 2.4. And then I've said, how many cycles are there in this whole thing? And I've multiplied this by that, to see what is the error per cycle, and we've got these figures 0.003 and so on. All of them are less than 0.1, although a couple of them are quite close to it. And what I found similar things to this with other ones, that in general we can say if we find a cycle using CATS, as long as it's got at least a couple of cycles present, these have got hundreds or thousands, that the error in the total number of cycles it's got, it can generally get it to 0.1 cycle or better. So that means in a case where we have 1,000 cycles, we can measure the cycle period to 1 part in 10,000, or if we've got 100 cycles, to 1 part in 10 hundreds or 1,000. So that's it. It can identify where the peaks are. Now it varies a little bit because some cycles are very strongly present, and we expect to get a slightly better measure. So we have got a bit better measure on the annual one, and a little bit less on these ones. But as a general rule, we can expect to get cycles measurements, the positioning of them at the things, to 0.1 of a cycle, and so that tells us when we find a cycle about how accurately we can expect to know the cycle period. So this is interesting for that.
So you have a range of accuracy here.
Yeah. So this is two things. It's one is the cycles in those commodities, but the other one is how accurately can we measure cycles.
Yeah. Ray Tomes of the Cycles Research Institute. We've got a graph up here on the screen. Price of rice in China. What do we have here, Ray?
We've got in China, we've got measurements going back to before 1000 AD up to 1900 of the price of rice. What this has done, we've simply taken it's only measured once per decade, and we've taken a smoothing. We've smoothed it by a 3-term moving average and subtracted that from it, so we've got the deviations from that 3-decade average. So we're emphasising the short-term fluctuations around the period of 30 years, and we see that we have got the little red marks are at regular 30.74 year intervals. So we might call this a 31-year cycle, and you can see that to begin with it's very strongly got a 31-year cycle. There's some missing data there, and at these places it's got smaller peaks at 31-year intervals. Sometimes there's a little double peak on that one, but there seems to be a 31-year cycle. Now, there's before this, I've heard of 31-year climate cycles in Africa, not in other places. You may remember that when we did Afanasiev's cycles, the lunar cycle of 9.3 years, he said there's a secondary cycle, which is the interaction of that cycle with the seasons, and that the period he got for that was 9.3 divided by 0.3 equals 31 years, the secondary cycle. So if the rainfall is biased towards some seasons, then that cycle is likely to show, and so that's supporting that evidence. And we don't have a lot of series. We don't have as much data from Asia and Africa as we do from some of the other continents. But Chinese ones, the good thing about them is they often run a long way back.